Pulcinella, and I'm forecasting relative sea level rise and analyzing flood exposure with a changing climate on the Texas and Louisiana coast. We do this study in this area because of high population in industrial areas, as well as the history of flooding due to hurricane storm surges, particularly Hurricane Katrina and Harvey, but also many others. So I'm going to go through and summarize some of the figures and hope that you'll have some time to read some of the other information. This is the tide gauge data from Galveston, Texas, which reports a 6.51 millimeter per year sea level rise rate there, which is more than twice the global average of about 3 millimeters per year. This is true of most tide gauge locations around the Gulf of Mexico, in the northern Gulf of Mexico. So this tide gauge signal, so there's something else going on here besides just the global mean sea level rise that's making this rate faster. And so these tide gauge data have within them the signal for the global mean sea level, as well as regional sea level oscillations due to some things like El Nino or something. And then also because the tide gauges are attached to land, they also record the vertical land movement. And that's what this map is showing. So we can extrapolate from the tide gauge data the downward vertical land movement in these areas. And that's all due to some geologic processes such as sediment compaction and also some anthropogenic influences such as like hydrocarbon extraction. So we extrapolate those background rates, and then we can add to them the global mean sea level rise scenarios that have been developed from global climate models. So low scenario being 3 millimeters per year, resulting in 0.3 meters by 2100, and increasing all the way to the extreme scenario, which results in 2.5 meters by 2100. This is a schematic of everything that goes into these relative sea level rise rates. So hopefully you'll get to take a closer look at that, everything that goes into them and what they're derived from. And the reason the approach that we use results in deep uncertainty, because there's uncertainty in the global climate system, there's uncertainty in global climate models. There's uncertainty about anthropogenic fossil fuel emissions, right? So there's a lot that goes on with uncertainty, and following certain methods that have been semi-developed over time and going through literature review, we can figure out that we need to get a range of scenarios to use for risk assessment, and that's what we've done here. So we've chosen the intermediate, high, and extreme scenarios and applied them to all locations along the northern Gulf of Mexico. If we take a closer look, now we can zoom in on any part of this map up here, and what we've done here is zoomed in on Galveston, and we look at the intermediate, high, and extreme scenarios over time. So the darker colors are closer to present day, and then the lighter colors are 2100. So we were able to do not only geospatial analysis of the flooding, but also temporal analysis of the flooding. And then these GIS layers can be used for overlay analysis for risk assessment of many different things. For this example, I've just included some critical infrastructure, but these can be applied to any number of studies. We've done a previous study where we used that overlay analysis to study transit issues, and so other people can do things like wastewater treatment plants or any other thing that may apply to risk assessment. And then, of course, we still need to include the hurricanes, right? So this is these are charts of Atlantic hurricane numbers here. There's total storms, hurricanes, and major hurricanes, and same setup here for landfall. So you can take a look at those trends. And then the storm surge history shows that the half of the worst storm surges have actually happened in the last 20 years. So in order to apply this, this is from previous publication, but methodology needs to be improved. But this is where we take a storm surge model, and then we add some number of feet of sea level rise to that to see how the inundation area changes over a period of time with sea level rise. So hopefully you can take a look at my conclusions, and I think my time is up. So thank you very much.